Okay, we are now back. This is what we call a practicum. The word practicum comes from the word practice, or English has taken the word practice out of practicum, which was probably one of those Latin words that goes back to the ancient times of Rome. Practicum means just that. We're going to practice something. And in this first few weeks, I'm asking you to learn specific skills so that you may use them in the laboratory. Also, these specific skills you'll use the rest of your life if you have any kind of job that involves measurement. If you cook in your house, you'll have to use recipes, which will involve these same basic skills. All right, so for our measurement practicum, if you've got your worksheet in front of you, just follow along. It says, please use the tape measure provided, that's this right here, to obtain measurements of various objects around the classroom. 1. Now, please be aware, anytime you see a circled number, this is something that you will want to answer. Linear measure is a measure of, is it length or volume? Now, we've not discussed volume yet, so therefore the proper answer must be length, and so we're going to circle length. It says, using your tape measure, hold the tape measure so the zero end is even with one edge of your object, and stretch the tape along or across the object and read the number which is closest to the opposite edge from 0, just like I'm doing right now. I have an example here where I measured an index card and we came out there were approximately 11 marks, so the object is approximately 11 centimeters across. If you're using a tape with the small marks between the numbered lines, the millimeters, if something comes out in between, you count 92, 1, 2, 3, 4, so this would be 92.4, or in the case of this, where it didn't come out quite right, it was 11.4 centimeters. All right, so now we're going to turn it over. Now, we're not going to be doing all this because some of this you'll need to come in and see me before school or right after school and get it done. But we are going to do most of the common ones here so that you can figure this out. Okay, it says your desktop. Well, the desktop from one side to the other is exactly 60 centimeters long. So I'm going to write 60 cm. That's the abbreviation for centimeters. Put that down on the floor. And I'm going to go across. And since I can already tell that this is not as wide, I'm going to use this as my width. That's 44.5. 44 and a half or 44.5 centimeters, and we can round this up using this as our guide. We can round this up to 45 centimeters because I want you to use whole numbers to begin with. Then it asks your textbook. Well, just so happens we have a handy dandy textbook here in our desk. We'll pull it out, and for our textbook I'm going to lay down the zero end up here at the top, pull it down, and I see that it's 28 centimeters long. The biggest number usually being the length, so 28 centimeters. And you know, some places it really does matter what is length and what is width, but for us in the 6th grade right now, the longest number will be length and the shorter number will be the width. Across the book, it's 22 centimeters right there. Then it wants to know how high is your desktop from the floor. Well, I'm going to turn the tape measure around so the zero end goes off the edge here. I am away from the camera, I'm sorry, but I'm just going to let this hit the floor, and I'm going to tell you that it is 72 centimeters from the floor. Now the next the next two questions have to do with you. What is your height? That's from the floor to the top of your head, and your waist around your belly button. Then I want to know a square on the floor. So let's just gently move the desk out of the way here. And we're looking at a square here on the floor. And I can tell you for a fact these squares are exactly 1 imperial foot. But let's just see how long one is in the metric system. In our case right here, it is 30 and a half. And if I go the other way, And I'm in the way, and I know I am. My dad always said I made a better door than I do a window. But let's do it anyway. 30.5 again. So these floor tiles are perfectly square. Perfectly square. So it's 30.5 centimeters and 30.5 centimeters. Or we can round that up to 31 centimeters and 31 centimeters. The next thing that I'd like you to do is I want you to figure some square area. Now, square area is just that. It's the total flat surface. Okay, square area has to do with flat surface. And it took us a while in class to figure that one out. But we did actually figure that one out all on our own. And I'm going to be doing some math here on the desk, so just follow along with me here. So it says, what is the area of your desktop? Hint, multiply the two numbers in number 2. Remember, we had 60 times 45. So 60 times 45. 5 times 0 is 0. 5 times 6 is 30. 0. 4 times 0 is 0. 4 times 6 is 24. 0 plus 0 is 0. 0 plus 0 is 0. 3 plus 4 is 7. And 2,700 square centimeters. So if I drew square centimeters here, I would get 2,700 little squares across the top of this. 2,700 centimeters, and then I'm going to put a little 2 up here for squared because I'm doing 2 dimensions. Then it wants to know what is the area of a floor tile. Well, the area of a floor tile is 31 times 31. 1 times 1 is 1. 1 times 3 is 3. 0. 3 times 1 is 3. 3 times 3 is 9. Whoops. 1. 3 plus 3 is 6. Bring down the 9. 961 centimeters squared. Then it wants to know how many tiles there are on the floor. Now, we've done this in our classroom, and I'm just going to go ahead and fill this one in for you. It is 28 across, and it is 27 from wall to wall that way. So 28 tiles this way across, and if we add 2 for the counter that we have here, and it's 27 from wall to wall this way. So what is the square area of one tile? Well, we've got that up here, 961 centimeters square. I guess I repeated that question. And then it wants to know what is the square area of the room. Well, we're going to need to know how many tiles are on the floor. So let's just do that. 28 times 27. 28, 27. 8 times 7 is 56. 7 times 2 is 14, plus 5 is 19. 0. 2 times 8 is 16. 2 times 2 is 4, plus 1 is 5. 6. 9 plus 6 is 15. 2 plus 5 is 7. So there are 756 tiles on the floor. The question wants to know is what's the square area? Well, I know there's 961 square centimeters in a tile. So 756 tiles. 6 times 1 is 6. 6 times 6 is 36. Carry the 3. 6 times 9 is 54 plus 3 is 57. 0. 5 times 1 is 5. 5 times 6 is 30. Carry the 3. 5 times 9 is 45 plus 5 is 48. 0, 0. And I use the zeros as placeholders. I'm not ashamed to do that. I grew up in the 60s and 70s, so that's what we were taught to do. 7 times 1 is 7. 7 times 6 is 42. Carry the 4. 7 times 9 is 63. Plus 4 is 67. So 6 plus 5 is 11. 7 plus 7 is 14. Plus 1 is 15. 8 plus 2 is 10, plus 5 is 15, plus 1 more is 16. 7 plus 4 is 11, plus 1 more is 12. And 1 plus 6 is 7. So there are 726,516 centimeters squared on the floor of our classroom right here. If If I wanted to find out how many meters, all I would do is divide this by 1,000. Okay, 1, 2, 3. No, it'd actually be 10,000 because 1,000 times 1,000 is 10,000 if I wanted to know the square meters. Thank you. I heard that out there. 10,000 square centimeters in a meter. So I've got 1, 2, 3, 4 zeros. I'm going to move the decimal. Here's where if you just know how to move the decimal, the metric system is really cool. 1, 2, 3, 4. There are 72.6516 meters squared on the floor. Isn't that cool? And we have just done the measurement portion of this practicum. And we've just done linear measure and square area, which is part of linear measure.